Everyone's seen a telephone. Almost no one has actually thought about what it meant to command an army with one. For most of World War II, the German military ran one of the most sophisticated, most brutally efficient command networks in the history of warfare. Not because of tanks, not because of aircraft, not because of the sheer number of soldiers they could throw at a problem, but because of wire. Copper wire stretched across thousands of kilometers of occupied Europe, buried under roads, strung along telegraph poles, threaded through forests and mountains and bombed out cities. Wire that carried voices, and more importantly, wire that carried teletype, the kind of communication that didn't crackle, didn't fade, didn't get picked up by enemy radio operators scanning the airwaves at 3 in the morning. And yet almost nobody talks about it. You'll find documentaries about Blitzkrieg. You'll find hours of footage about panzer divisions and the Luftwaffe and the Wolf's Lair. But the thing that actually held all of it together, the invisible nervous system that let a German general in Paris give an order that reached the Eastern Front in under 3 minutes, that almost never gets discussed. And that is a mistake. Because once you understand how and why the German Higher Command leaned so heavily on landline communication, you start to understand something deeper about the way the Wehrmacht actually functioned. You start to understand why certain operations succeeded with terrifying precision and why others collapsed the moment that wire went dead. If you've never thought about this before, stick around, because this is one of those stories where the details change everything. And if you want more of this kind of deep dive into the machinery behind the war, the stuff that doesn't make it into the highlight reels, go ahead and subscribe right now. This is exactly the kind of thing we dig into. Let's start at the beginning, not with the war itself, but with the problem that every military in human history has faced from the moment armies got too big to control, with a shout and a signal flag. Communication is command. That's not a metaphor. That's a literal operational truth. The moment a commander cannot transmit his intentions to the units under him in a reliable, timely, and secure way, he has lost control. He might still have troops. He might still have equipment. But without the ability to direct them, those assets become essentially inert. Or worse, they act on outdated information and make catastrophic decisions based on a situation that no longer exists. This was not a new problem in 1939. Armies had been wrestling with it for centuries. Napoleon famously built a system of signal towers across France, optical telegraph lines that could relay a message from Paris to the Italian border in a matter of hours. The American Civil War saw the first widespread military use of the electric telegraph, with both sides laying field wire and using it to coordinate troop movements in ways that had never been possible before. By World War I, the problem had evolved again. Armies were so large, fronts so extended, and combat so intense that the telegraph and even early telephone lines were perpetually cut by artillery, disrupted by the chaos of trench warfare, and fundamentally inadequate for the speed of modern operations. By the time World War II began, the Germans had thought about this problem more seriously than almost anyone else, and their answer was not a single technology. It was a philosophy of communication built around a core principle: if an enemy can hear your message is already compromised. And in a war, where operational surprise was one of Germany's greatest tactical weapons, the security of communication wasn't just a technical concern, it was existential. So let's talk about what wire communication actually meant in this context. When we say wire, we mean landline telephone and teletype systems, physical copper cable, either laid across the ground, buried underground, or strung along existing infrastructure like railway lines and telephone poles. These were not improvised field expedients. They were engineered systems. The Germans used a layered approach. At the strategic level, at the very top of the command structure, the Oberkommando der Wehrmacht, the OKW, and the Oberkommando des Heeres, the OKH, operated through a combination of permanent landline infrastructure and the Reichspost, the German National Postal and Telecommunications Network. This was the same network that handled civilian communications, but it had been deeply integrated into military planning long before the war began. Cables ran under streets, under rivers, under the ground itself. These were not easy targets for enemy sabotage. You couldn't bomb a buried cable the way you could knock out a radio relay station. You couldn't triangulate its position, it simply existed, invisible and functional. At the operational level, the level of army groups and individual armies, the Wehrmacht maintained dedicated military telephone exchanges. These were called Fernsprechanlagen, long-distance telephone systems. They operated through a hierarchy of exchanges, just like civilian phone networks, except the hierarchy was military in structure. A call from Army Group Center could be routed through regional exchanges to reach a specific corps headquarters, with operators manually connecting lines and monitoring traffic. It sounds slow. It was actually remarkably fast by the standards of the time, and more importantly, it was reliable in a way that radio simply was not. And then there was teletype. This is where things get genuinely fascinating, because the German military's use of teletype communications was not just widespread. It was sophisticated in ways that most people never realize. The teletype, or Fernschreiber in German, was essentially a typewriter connected to a telecommunications line. You type a message at one end, it transmits electrically over the wire, and it prints out at the other end in typed text. No voice, no interpretation, no possibility of mishearing a word under artillery fire. The message arrives exactly as it was sent, word for word, character for character. For military communication, this was revolutionary. A commander didn't need to worry about a signals officer garbling an order. He didn't need to read it aloud in a room full of people who shouldn't hear it. He typed it, it transmitted, it printed. Clear, accurate, permanent. But the Germans took teletype communications several steps further. The most significant development was the integration of the Lorenz cipher machine into teletype transmissions. The Lorenz SZ40 and its successor the SZ42, known to the British codebreakers at Bletchley Park as Tunny, were used to encrypt teletype messages sent between the highest levels of German command, Hitler's headquarters, Army Group commanders, the OKW and OKH. These messages were typed, automatically encrypted by the Lorenz machine, transmitted over either landline or radio link, and then decrypted at the other end by another Lorenz machine. The result was a communications channel that German commanders believed was essentially unbreakable, and for a long time they were not entirely wrong about that. This matters enormously when you try to understand why wire was so central to German higher command. Because at the strategic level, the decision to use wire wasn't just about reliability or clarity. It was about the fundamental assumption that wire communications were secure in ways that radio simply could not be. Think about what radio communication actually means in wartime. You broadcast a signal. That signal travels in every direction. Anyone with a receiver tuned to the right frequency can pick it up. Now, if that signal is encrypted, picking it up doesn't necessarily mean reading it. But the act of transmission itself is detectable. The enemy knows you're transmitting. They can triangulate your position. They can measure the volume of traffic. Even if they can't read your messages, they can watch the patterns. A sudden spike in radio traffic from a particular army group's frequency often meant something was about to happen. The British became extraordinarily good at this kind of traffic analysis, reading operational intentions not from message content, but from the shape of communication itself. Wire communications did not have this vulnerability. A conversation carried over a buried landline cable cannot be intercepted by anyone who doesn't physically tap that specific cable. It emits no signal that can be detected by a distant antenna. It produces no radio frequency signature. It leaves no electronic footprint in the electromagnetic spectrum. For a military doctrine built on surprise and deception, the security advantages of wire were not just significant. They were fundamental. Now, here's where the story gets complicated, because the Germans knew all of this, and yet they also knew that wire had catastrophic limitations, particularly in the kind of mobile, fast-moving warfare that became the defining feature of the Eastern Front. Let's step back and look at the actual geography of German operations. By the summer of 1941, Germany was fighting across a front that stretched from the Arctic Circle to the Black Sea. By the following winter, that front measured over 2,700 kilometers. And unlike Western Europe, where the Germans could exploit existing French and Belgian and Dutch telephone infrastructure, the Soviet Union presented an almost entirely different challenge. Russian telecommunications infrastructure in 1941 was sparse by Western European standards. The wire networks that did exist followed railway lines and major roads. In the vast spaces between, there was almost nothing. No buried cables, no pole lines, no exchanges, just distance. Enormous, brutal, war-consuming distance. This forced the Germans into a dual-track approach that created one of the most interesting communication structures of the entire war. At the strategic level, where headquarters were relatively stable and distances between key nodes were manageable, wire and teletype remained the primary means of communication. At the tactical level, where units were constantly moving, wire was supplemented aggressively by radio. But the distinction between those levels was not always clean, and the friction between the security of wire and the flexibility of radio caused real operational problems throughout the war. Let's talk about the strategic level in more detail, because this is where the German approach to wire communication was most deliberate and most revealing. The Führerhauptquartier, Hitler's field headquarters, went through numerous iterations during the war. Wolfschanze in East Prussia, Werwolf in Ukraine, Felsenest in the Eifel. Each of these compounds was constructed with telecommunications as a primary concern, not an afterthought. Before any headquarters became operational, signals engineers were dispatched to run landlines to the nearest existing telephone exchange nodes and to establish secure teletype connections to key command centers. The construction of a new headquarters was as much a signals engineering project as it was a construction project. At Wolfschanze, which served as Hitler's primary headquarters for much of the war on the Eastern Front, the telecommunications infrastructure was extraordinary for its time. Multiple landline connections ran to the OKW and OKH headquarters at Mauerwald, just a few kilometers away. Dedicated teletype circuits connected to Berlin, to Army Group headquarters, to the major rail coordination centers. The compound had its own telephone exchange, its own Fernschreiber room with multiple teletype machines running continuously, its own cipher section using Lorenz equipment for the highest grade traffic. The entire apparatus was designed around the assumption that the most important communications would travel by wire, and that radio would be used only when wire was physically unavailable. This was not accidental. It reflected a deep institutional understanding within the Wehrmacht signals branch, the Nachrichtentruppe, about the vulnerabilities of radio communication. German signals doctrine, as developed through the 1930s, explicitly emphasized the importance of wire networks for higher command, and the training of signals officers included detailed study of how to extend wire networks rapidly during advances, and how to protect them against disruption during defensive operations. The Nachrichtentruppe were not glorified telephone operators. They were engineers, tactical planners, and security specialists who understood that the cable they were laying might be the most important weapon on the battlefield. Let's talk about teletype in more detail, because I think this is where the average person's understanding of World War II communications falls apart most completely. Most people, when they think about military communication in World War II, think about radio operators in jeeps, code books, Morse code, walkie-talkies. And all of that existed, but at the level of higher command, the level where strategic decisions were made and operational orders were issued, the primary written communication medium was the Fernschreiber, the teletype. Why? Because voice communication, even over a secure landline, is inherently ambiguous. People misspeak. Accents cause misunderstanding. Background noise interferes. Orders given verbally must be written down by the recipient, and in that transcription process, errors creep in. A misheard unit designation, a garbled grid reference, a number spoken with ambient noise in the background. These were not trivial problems. In military operations where the difference between Hill 112 and Hill 212 might mean the difference between a successful defense and a catastrophic collapse, ambiguity in communication was not acceptable. The Fernschreiber eliminated ambiguity. The message printed exactly what was typed. There was no interpretation required. There was no transcription error. The receiving officer held in his hands the exact text of the sending officer's message. This was, in an era before computers, one of the most reliable ways to transmit complex technical information over long distances. And German higher command generated enormous quantities of complex technical information. Operational orders from OKH to Army Group headquarters were not simple. They specified unit assignments, movement timetables, supply allocations, boundary lines between formations, objectives, timing, the disposition of reserves, coordination with Luftwaffe support, and dozens of other variables that had to be communicated without error. Attempting to convey all of this information reliably by voice, even over a secure telephone line, was inefficient and error-prone. Teletype made it manageable. The volume of Fernschreiber traffic through a major German headquarters was staggering. At Wolfschanze during active operations on the Eastern Front, the teletype room operated around the clock with multiple machines running simultaneously. Messages arrived and departed continuously. Staff officers monitored incoming traffic, sorted it by priority and recipient, and ensured that critical operational messages reached the appropriate officers without delay. There was a whole administrative infrastructure built around managing this flow of written electronic communication, an infrastructure that modern observers would recognize as essentially analogous to what email networks do today in large organizations. But here's what makes it even more interesting. The Germans didn't just use teletype for passing routine orders. They used it for real-time operational coordination at a level that would have been impossible with any previous communication technology. Consider the coordination required for a major offensive operation. Artillery must begin preparation at a specific time. Infantry units must reach their start lines before first light. Panzer formations must be positioned to exploit breakthrough points that don't yet exist. Air support must be requested, approved, scheduled, and coordinated with ground movements. Supply convoys must be routed to reach forward depots before the operation consumes existing stockpiles. All of this coordination had to happen between multiple headquarters simultaneously, with information flowing up, down, and laterally through the command structure. Wire and teletype networks made this kind of coordination possible in a way that messenger traffic, or even voice telephone alone, never could have. A request for air support could be typed at a corps headquarters, transmitted over teletype to Army headquarters, forwarded to the relevant Luftwaffe liaison, approved, and confirmation transmitted back, all within an hour. The same process using physical written messages carried by dispatch riders might take the better part of a day. During fast-moving operations, a day was an eternity. Now let's talk about something that often gets overlooked in discussions of German communications: the relationship between wire communications and German operational security more broadly. One of the things that made German operations so difficult for the Allies to counter in the early years of the war was the sheer unpredictability of German intentions. The Germans consistently managed to achieve surprise, to strike where they were least expected, to shift forces rapidly, and attack from unexpected directions. And while much of this is attributed to tactical innovation, the security of German communications played a huge role that is rarely acknowledged. Every time the Allies tried to read German intentions in advance, they were working from fragmentary information. Aerial reconnaissance could show troop concentrations but not explain them. Prisoner interrogations produced tactical intelligence but rarely strategic insight. Agent networks were penetrated and manipulated, and radio intelligence, the great Allied advantage that Ultra eventually provided, was most effective against German Enigma-enciphered radio traffic. Against wire communications, it was essentially helpless. This is not a small point. During the planning phase for Operation Barbarossa in 1941, the Germans conducted much of their strategic communication over landline. Troop movements were coordinated through existing railway infrastructure, with orders transmitted by teletype. The radio silence that preceded the invasion was not absolute, but it was enforced with unusual discipline, and the complement to that radio silence was the heavy reliance on wire for the communications that radio silence was meant to conceal. The Soviets, watching German radio traffic patterns, saw relatively little that alarmed them. They could not see the wire. Similarly, during the planning for Fall Blau, the great German summer offensive of 1942 that drove toward Stalingrad and the Caucasus, strategic planning communications between OKH and Army Group headquarters moved primarily over landline. When a German officer was killed in a light aircraft in June of 1942, and documents relating to the operation fell into Soviet hands, the Germans changed their plans partly, but did not suffer the immediate catastrophic communication compromise that such an event might have caused if their planning had been conducted primarily over radio. Because most of the operational details had moved over wire, there was no radio traffic record that the Soviets could exploit to understand what they had captured. And then there is the question of the Lorenz cipher and its role in landline security. The Lorenz SZ machines were attached to teletype circuits, primarily those connecting the highest level of German command. When a teletype message was transmitted over a radio link, the Lorenz machine would encrypt it automatically, producing a stream of encrypted characters that were transmitted and decrypted at the other end. When the link was a direct landline, the encryption was still applied for the highest grade traffic, because even landlines could theoretically be tapped if an enemy agent gained physical access to the cable. the British breaking of Lorentz at Bletchley Park, which was actually accomplished before the breaking of some naval Enigma settings and using the world's first programmable electronic computer, Colossus, is one of the great intelligence achievements of the war. But it is important to understand what this actually meant operationally. The British could read some of the highest-level German command communications that traveled over radio links, even when Lorentz encrypted. But German messages that traveled entirely over physical landline and were never retransmitted over radio were, from a practical standpoint, invisible to British signals intelligence. They could not tap a buried cable in France from a station in England. This created a fascinating asymmetry. The German communications that the British could read through ultra were precisely those that traveled by radio, which were also typically the communications of mobile units in the field where wire was unavailable. The strategic communications of the highest command levels, the conversations between Hitler's headquarters and army group commanders about fundamental operational decisions, those most often traveled by wire and were largely inaccessible to Allied signals intelligence. Ultra gave the Allies a window into German military thinking, but it was a window that looked primarily at the tactical and operational middle levels of the German command structure, not consistently at the strategic summit. This is why certain German decisions appeared so surprising to Allied planners even after Ultra was well established. The communications that drove those decisions were not traveling by radio. Now let's move to something that really illustrates how central wire communications were to German operations. Let's talk about what happened when the wire went down. The Eastern Front presented challenges for wire communication that were almost impossible to fully solve. The distances were enormous. The terrain was harsh. Soviet partisans, who became increasingly effective from late 1941 onward, understood exactly what they were doing when they cut telegraph lines and severed telephone cables. And the speed of German advances during successful operations often outpaced the ability of signals engineers to extend wire networks forward. During Operation Barbarossa in the summer of 1941, German advances were so rapid that wire networks perpetually lagged behind the forward edge of battle. Panzer formations raced forward, leaving their communications infrastructure trying desperately to keep up. Signals companies with wire-laying vehicles followed the advance, unreeling cable behind them as fast as they could, but the speed of the armored advance was simply greater than the speed at which wire could be laid and tested. This forced a greater reliance on radio at the tactical level than German doctrine actually preferred, and it created the conditions for communication breakdowns that had real operational consequences. The famous confusion during the early phases of the advance toward Moscow in the fall of 1941 was partly a command and control problem rooted in communications. As German forces approached the city and the distances stretched communication networks to their limits, the clarity and security of higher command communications degraded. Orders became more ambiguous. The picture at Army Group headquarters became less precise. The feedback loop from forward units to commanders became slower and less reliable. By contrast, during the more static defensive operations of 1943 and 1944, when German forces were generally on the defensive and holding established positions, wire communications infrastructure was much more robust. Lines could be buried rather than just laid on the surface. Multiple parallel routes could be established to provide redundancy if one line was cut. Exchanges could be set up in permanent or semi-permanent shelters. And the result was that defensive operations were generally better supported by communications infrastructure than offensive ones, which had a real effect on German defensive performance. This created a somewhat paradoxical situation. The German higher command's reliance on wire made them more effective when they were stationary and less effective when they were moving. In the early years of the war, when German forces were advancing rapidly, this paradox was manageable because tactical radio communication could partially compensate. But as the war turned against Germany and the nature of operations shifted, the wire networks that had been painstakingly built up during periods of relative stability became both a genuine operational advantage and, in a sense, a constraint on flexibility. Let me give you a specific example of how this played out. The German defensive network in France in 1944, before and immediately after the Allied landings at Normandy, was deeply dependent on landline communications. The French telephone and telegraph network had been heavily integrated into German military communications from the moment of occupation in 1940. German signals units had worked for 4 years to extend, reinforce, and supplement the existing French infrastructure to create a communications network that served German military purposes. By 1944, this network was extraordinarily dense, with multiple connections between major headquarters, buried cables in sensitive areas, and substantial redundancy built in against air attack. Allied air campaigns before and after D-Day deliberately targeted this infrastructure. Telephone exchanges, relay stations, and railway communication systems were attacked both directly and through attacks on the transportation network that logistics and communication infrastructure shared. The results were significant. The ability of German higher command to coordinate the response to the Normandy landings was degraded by the disruption of their communications network, contributing to the confused and delayed nature of German decision-making in the critical first days after June 6th. But the degradation was not immediate or complete. The depth and redundancy of the German wire network meant that cutting it in one place simply caused traffic to route around the break through an alternative path. It took sustained, heavy, systematic air attack over weeks to genuinely compromise the network's effectiveness. And even then, the Germans showed remarkable ingenuity in maintaining functionality, using dispatch riders to bridge gaps, shifting traffic to different circuits, and improvising connections through whatever infrastructure remained intact. This resilience was not accidental. It was built into the design of the network from the beginning, reflecting the German military's deep understanding that communications infrastructure was a target and that surviving attacks on it required redundancy and flexibility. Now, let's talk about some of the specific technical systems and personnel who made all of this work, because the human side of German military communications is every bit as interesting as the technical side. The Nachrichtentruppe, the German Army's signals branch, was one of the most technically sophisticated formations in the Wehrmacht. Unlike some armies where signals units were something of an afterthought, the German Army treated communications as a core operational function. Signals officers attended dedicated schools, studied telecommunications engineering alongside military doctrine, and were expected to understand both the technical and operational aspects of their work. At the company level, a standard German infantry division in the mid-war period included a Nachrichtenkompanie, a signals company, that was responsible for maintaining communications within the division and with higher and adjacent headquarters. These signals companies operated field telephone switchboards, ran wire-laying parties to extend and maintain landline networks, operated radio sets when wire was unavailable, maintained messenger services for when neither wire nor radio was practical, and managed the administrative infrastructure of message handling and distribution. The wire-laying parties deserve special attention because their work was both technically demanding and physically dangerous. Laying wire under combat conditions meant moving through terrain that was often under fire, unreeling heavy cable from drums mounted on vehicles or carried on shoulder reels, making connections that had to be reliable under adverse conditions, and doing all of this rapidly enough to keep pace with tactical requirements. Wire laying was not a safe rear area activity. In many operations, it was conducted under direct enemy fire, because cutting the wire was a priority for any enemy force trying to disrupt command and control. The cables themselves came in several varieties suited to different purposes. Feld cable, standard field cable, was lightweight and relatively easy to handle, but was also relatively fragile. It was suitable for laying quickly across short distances, but not for routes that needed to remain in use for extended periods. Starkstrom cable, more robust armored cable, was used for important routes that needed to withstand physical abuse, vehicle traffic crossing the cable, enemy attempts to cut it, and the general wear of field conditions. For the most critical routes, buried cable was used, requiring excavation that slowed installation significantly, but produced a connection that was vastly more resilient against all forms of attack and interference. The choice of which type of cable to use where required, genuine technical judgment. Using heavy cable everywhere was logistically impossible. Using light cable everywhere produced a communications network that was fragile and easily disrupted. Getting this balance right, matching the type of wire infrastructure to the operational situation, was one of the core skills of the Nachrichtentruppe, and one of the things that distinguished effective German signals practice from less sophisticated approaches. Now let's talk about the Fernschreiber itself in more operational detail, because the mechanics of how teletype communication actually worked in a German headquarters tells you a great deal about the broader communication system. In a major headquarters, the Fernschreiberraum, the teletype room, was one of the most critical spaces. It was typically staffed around the clock, with shifts of operators who were trained specifically in Fernschreiber operation, which was a distinct skill from telephone operation or radio operation. The operators were responsible not just for physically sending and receiving messages, but for the administrative management of message traffic, which was both substantial and complex. Incoming messages were date and time-stamped on receipt, logged in a message register, sorted by classification and addressee, and delivered to the appropriate staff section. Outgoing messages were drafted by staff officers, submitted through a message center where they were logged and assigned a transmission reference number, and then transmitted in priority order. Priority categories determined which messages went first when traffic volume exceeded the capacity of the available circuits, which during active operations was a frequent occurrence. The physical layout of a Fernschreiber installation reflected these operational requirements. Multiple machines were typically arranged in rows, each connected to a specific circuit. One machine might be connected to the direct line to OKW in Berlin, another to Army Group North, a third to the Luftwaffe Liaison Headquarters, a fourth to the administrative rear area. The operators worked at their machines continuously, monitoring for incoming traffic, transmitting outgoing messages, and maintaining the running log that accounted for every message that passed through the installation. When the Lorenz cipher was in use, the process was more complex. The plain text message was typed into the Lorenz machine, which produced an encrypted output. This encrypted text was then transmitted to the receiving station's Lorenz machine, which, set to the same starting key, automatically decrypted it back into plain text. The operators had to manage the initial key settings and ensure that sending and receiving machines were synchronized, a process that itself required training and attention to detail. Key settings were distributed in advance through secure channels, typically physical one-time key sheets carried by courier rather than transmitted electronically for obvious reasons. The overall impression from examining how this system actually functioned is of a remarkably sophisticated information management system. One that was built for the specific demands of military command rather than adapted from civilian practice. The Wehrmacht had thought hard about how information needed to flow in wartime conditions and had built an infrastructure and a set of procedures specifically designed to make that flow as reliable, secure, and fast as possible. Let's zoom out now and look at the broader strategic implications of what the German approach to wire communications meant for Allied planning. One of the fundamental challenges that Allied commanders faced throughout the war was the problem of reading German intentions. They knew, broadly, the strategic situation. They could see German order of battle from captured documents, prisoner interrogations, aerial reconnaissance, and increasingly from signals intelligence. But reading intentions, understanding what the Germans were actually going to do, rather than what they were capable of doing, was consistently difficult, and much of that difficulty traced back to the communications security that wire networks provided. Consider the position of Allied intelligence analysts in the months leading up to major German offensive operations. Ultra gave them access to an enormous volume of German military communication, but as we've already noted, this access was primarily to radio-transmitted traffic. Communications that traveled exclusively by landline were essentially invisible, and German operational planning, particularly in its early stages, was precisely the kind of communication that moved by wire at the highest levels. The planning for Operation Citadel, the German attack on the Kursk salient in the summer of 1943, is an interesting case study. This was actually an operation where Allied intelligence, informed partly by a remarkably effective Soviet intelligence penetration of German planning, had substantial advance warning. But the interesting thing is that the advance warning came not from signals intelligence against German radio traffic, but from agent sources and from the reading of Enigma traffic as the plan moved down from strategic to operational and tactical levels. The highest level planning discussions between Hitler's headquarters and the Army Group commanders largely moved by wire and left no electronic trace that British or American signals intelligence could exploit. It was only as the plan moved down the command chain, reaching corps and division levels where radio traffic was unavoidable, that signals intelligence began to provide clearer picture. By that point, the basic outline of the operation was already committed. The damage that might have been done by earlier warning, by being able to read the strategic level discussions during the planning phase, was unavoidably limited by the fact that those discussions traveled by wire. This pattern repeated throughout the war. Strategic decisions made at the highest levels of German command moved primarily by wire. The resulting operational orders moved by wire to Army group level. Only as they cascaded down through the corps and divisional levels did they substantially enter the radio spectrum, where Allied signals intelligence could intercept them. This inherent lag in signals intelligence coverage of the highest command levels meant that the Allies often understood what Germans had decided, rather than what they were deciding. The difference between those two things, in terms of the time available to respond, was operationally significant. Now let's talk about one of the most dramatic failures of German communications practice, a failure that illustrates precisely why the principles that wire communication enforced mattered so critically. One of the recurring problems in German military communication during the latter half of the war was the pressure to use radio when wire was unavailable. This pressure was real and understandable. Operations were moving. Wire networks couldn't keep up. Commanders needed to communicate. Radio was available, so radio was used. But every time highly classified traffic was transmitted over radio, even when encrypted with Enigma or Lorenz, it created risks. The British codebreakers at Bletchley Park worked continuously to break or to maintain the breaking of German cipher systems. Every time an operator made an error, reused a key setting, sent a crib that aided cryptanalysis, or transmitted an easily identified message format, it gave the British additional material to work with. The cumulative effect of radio transmission of high-grade traffic was a steady erosion of cipher security that wire communication would have prevented entirely. German signal security suffered from a fundamental human problem. The discipline required to avoid radio when wire was unavailable was genuinely difficult to maintain under operational pressure. A commander who needed to speak with a subordinate headquarters right now, who couldn't wait for wire to be laid, who was watching a tactical situation develop that required immediate coordination, that commander was not going to choose communications security over operational necessity. He was going to get on the radio. The Nachrichtentruppe understood this tension deeply. Signals officers repeatedly issued warnings and instructions about radio discipline. Training emphasized the dangers of unnecessary radio transmission. Procedures were put in place to minimize avoidable radio traffic. But in the brutally practical environment of combat operations, these measures could only go so far. The pressure of operations consistently drove commanders toward radio when wire was unavailable, and this created the ongoing vulnerability that Allied signals intelligence steadily exploited. The contrast with what happened when wire was available is instructive. German headquarters that operated from fixed positions with robust landline infrastructure consistently showed better communications security than those operating in mobile conditions where radio was unavoidable. The security advantage of wire was not theoretical. It showed up directly in what Allied signals intelligence could and could not read. And what it could not read was precisely what traveled by wire. This is not to say that German signals security was uniformly excellent. There were periodic lapses in cipher security, errors in procedure, moments where operational urgency led to dangerous shortcuts. But these lapses tended to occur in the context of radio transmission, not wire transmission. The wire remained consistently secure in a way that radio, despite the best available encryption, could not fully match. Let's now turn to the practical question of how German wire communications actually affected specific operations, tracing the thread from communications infrastructure through to operational outcomes in ways that are concrete and specific. In the early summer of 1940, the German planning and execution of Fall Gelb, the invasion of France and the Low Countries, benefited enormously from communications infrastructure that had been carefully prepared in advance. German signals units had been forward-positioned and had conducted extensive preparatory work, establishing the wire networks that would support the offensive. When the attack began on May 10, 1940, higher command was able to maintain unusually clear and rapid communication with forward headquarters, contributing to the extraordinary pace at which German units were able to coordinate their advance through the Ardennes and toward the English Channel. The crossing of the Meuse at Sedan on May 13th, one of the pivotal moments of the campaign, was coordinated with a precision that would have been difficult without reliable communications between the attacking corps headquarters and the supporting Luftwaffe units providing ground attack support. This coordination moved partly over radio, but also partly over hastily established telephone connections, and the combination of the two, with wire providing the backbone of security for the most sensitive coordination, contributed to an execution that French commanders, operating with far less effective communications, simply could not counter at speed. Compare this to the situation on the Allied side. French Higher Command in May 1940 was operating through a communications network that was both slower and less secure than the German one. The French General Headquarters at La Ferté-sous-Jouarre was physically distant from the front and connected to forward headquarters through a telephone network that was not designed for the speed of German operations. Orders that needed to travel from GQG to Army Group to Army to Corps moved through this network at a pace that consistently left French commanders responding to situations that had already changed by the time orders arrived. The contrast in communications effectiveness was not the only factor in France's defeat, but it was a real and consequential one. Now consider the situation on the Eastern Front from a different angle. Soviet communications in 1941 were, in some respects, even more problematic than French communications had been in 1940. Soviet Higher Command relied heavily on telephone networks that were fragile and that the chaos of German advances disrupted catastrophically in the opening weeks of Barbarossa. Soviet Army and front commanders frequently lost communication with both higher headquarters and subordinate units simultaneously. In the resulting confusion, Soviet units continued to fight, but they fought without coordination, without knowing the overall situation, and without being able to respond effectively to the rapidly changing tactical picture. The Germans, by contrast, even in the mobile conditions of the advance, maintained better communications coherence through a combination of wire extensions from established networks, tactical radio within units, and a signals infrastructure that was designed to function under degraded conditions. The Nachrichtentruppe had practiced operating under the assumption that some communications would fail and had developed procedures for maintaining command when specific links went down. This procedural resilience, combined with the inherent robustness of wire-based networks where they existed, gave German Higher Command a consistently clearer operational picture than their Soviet counterparts. As the war progressed and Soviet communications improved dramatically, both through better training and through the introduction of Allied radio equipment provided under Lend-Lease, this advantage progressively narrowed. By 1943, Soviet operational communications had improved to the point where their command and control was genuinely competitive with German practice. By 1944, in some respects it had exceeded it, particularly in the ability to coordinate large-scale offensive operations across broad fronts, which required flexible, mobile communications that wire alone could not provide. The German insistence on wire for higher command, which had been an operational advantage in 1941 and 1942, was less relevant in a war environment that had become more mobile, more dynamic, and more damaging to fixed infrastructure. But here is the thing that I want to make sure doesn't get lost. Even as the strategic situation deteriorated, even as German forces were pushed back across the map, even as Allied air power systematically attacked the infrastructure that German wire communications depended on, the institutional commitment to wire communication at higher levels remained. German headquarters continued to prioritize wire connections. Signals engineers continued to lay cable and maintain networks under increasingly difficult conditions. The preference for teletype over voice for formal military communications persisted to the end of the war. This persistence was not stubbornness. It was a recognition that the principles that made wire valuable, security, clarity, reliability, the impossibility of interception without physical access, remained valid even in a losing war. Indeed, in some ways they became more valuable as the war turned against Germany. A military conducting defensive operations on multiple fronts, trying to preserve operational surprise for counterattacks and defensive shifts, needed communications security more urgently than a military that was advancing confidently. The wire network was not just a technical preference. It was a security tool that became more important as the margins of error shrank. Let's spend a moment on the human cost of maintaining these communications networks, because it is easy to talk about wire and teletype as abstract technical systems without acknowledging the extraordinary effort and danger involved in keeping them functional. Signals units suffered casualties throughout the war at rates that are rarely discussed in popular accounts. Wire-laying parties worked in the open, under fire, performing tasks that required both hands and considerable attention, making them vulnerable in ways that soldiers in covered positions were not. Line maintenance parties were sent out to find and repair breaks in cable lines, often in the dark, often under artillery fire, often in no man's land between opposing positions. Fernschreiber rooms in headquarters buildings were priority targets for air attack, and the personnel in them took casualties when those attacks succeeded. The operators themselves, Both telephone operators and teletype operators worked in conditions of significant stress. Heavy traffic, continuous operations, the pressure of handling messages that they knew were operationally critical, and the constant awareness that errors could have serious consequences. All of these factors made the signals branch a demanding environment. The fact that the communications infrastructure continued to function as effectively as it did through 4 years of total war is a testament to the professionalism and commitment of the Nachrichtentruppe personnel who maintained it. There is also the question of signals intelligence conducted against German wire communications by resistance movements and Allied special forces. The French resistance, the Polish resistance, and various other underground networks made attempts throughout the war to tap German telephone lines and to gather intelligence from wire communications. These efforts were partly successful and produced genuine intelligence, but they were also dramatically more difficult and dangerous than intercepting radio traffic. Physically accessing a German military telephone line required an agent to locate the cable, find a point where it could be accessed, make a physical tap without detection, and then somehow transmit what was heard through channels that were themselves under constant German counterintelligence scrutiny. The difficulty and danger of this process meant that wiretapping, while it happened, was far less systematic and productive than radio interception. German wire communications, even when they were physically